start with a definition. Also, I record all of my lessons, and they will be posted in your Google Classroom. So if you miss a day, it will be there. If you miss a day and it's not there, and that just means I forgot to post it. So remind me, and I'll post it. Okay, yeah, I got that covered. Now, some of you said that this was slope. Some of you said this was slope-intercept form. So let's start with, because slope-intercept form already has the word slope in it, let's give me a definition. What is slope? I like that. Rise over run. You got a different thing they use to explain it?
It's like which way the graph or the line can go. This or that.
This or that?
Yeah.
So, okay. Let's call it the tilt of the line. Okay. I like that. Do you know what I mean when I say that? Tilt of a line? How tilted it is? Yeah. Okay. All right. Anything else? Anybody? I could define slope for days. It's a great word. No? Okay. So what about the difference between positive slope and negative slope?
Positive makes the line go up.
In what way? What do you mean it goes up?
Like starts in the bottom left and goes up.
Very good. So when we look at a graph, it's just like we read words. How do you read words?
Left to right.
How do you read a graph? Left to right. So if I'm looking at this graph from left to right, if the line is going up, that means it has a positive slope. If the line is going down, it has a negative slope. Okay? Positive slope. So let's see, it goes up from left to right. Sorry, I'm not used to writing this many words. And negative slope goes down from left to right. L to R. Can y'all make out what my chicken scratch is saying? Just trust me, it's better since I got this pencil, but it still ain't good. Anything else? Just word vomit. Anything you've heard with slope. I'm looking for one more thing. Actually, two more. Well, one more thing specifically. We have a formula for slope. How we find the slope if we were given 2 points. Does anybody know what the slope formula is? That's slope-intercept form. Oh my goodness. That's good. That's okay. People get them confused. That's why I'm making such a big deal about it. Okay? I'm not mad at you. That's just the way I teach. So just get used to it. Sorry, I apologize.
X2 minus X1 over Y2.
That was a great try. Don't write that down. Didn't you tell me slope was rise over run?
No.
Who told me rise over? Oh yeah, rise over run. Sorry, thanks.
Oh.
You were tilted a line.
The other way?
Well, do y'all know what this means?
Yes.
Rise over run? Rise means how much we are going up or down. Run is how much we're going left or right. So which one needs to go on top of the slope? The Y's. Because the Y's are what's rising. Everything else in that formula is good, but the Y's need to be what's on top. The X's need to be what's on bottom. So let's fix that. It is y2 minus y1 over x2 minus x1. Which, from this formula, is how I'm going to get a little bit more shorthand. So if the slope formula is y2 minus y1 over x2 minus x1, sometimes we call that the change in y. Because how much am I changing? You just subtract where I ended from where I started. Right? Like if I had $100, but I used to have 20, how much did it change by? Because I subtract them, right? That's y2 minus y1. How much the y's are changing over how much the x's are changing. So that says change in y over change in x, which, again, I'm going to shorten that down one more time. The way that you'll probably see it written if you take like real math classes is delta y over delta x. That's a triangle. Okay, triangle y over triangle x. It looks like a triangle. It's a Greek letter. All that means is the change in y over change in x, but I didn't have to write it out. I just wrote delta y over delta x. Okay, but it means the same thing. So now, oh gosh, I forgot. What am I doing? What was all this? All this that I just talked about. Slope. This is all about slope. 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 Just the slope. Let's amend our slope formula. So sorry. I'm so sorry. M equals y2 minus y1 over x2 minus x1. These are just 2 points, right? 2 points. Some x1, y1, some point x2, y2. If I know 2 points, I can find the slope. We represent slope with the letter M. Did you know that? We represent slope with the letter M. So now back to our original question. What is the graph of y equals 4/5 x plus 2? And you guys said this was what? This equation was, you said it was in slope intercept form. Okay? I heard somebody already say, it was William, right? Y equals mx plus b. I like that. That is slope intercept form. What else do you know about it? Slope intercept form. Y equals mx plus b. Word vomit.
The B's the y-intercept.
The b is the y-intercept. Okay. And what is a y-intercept? You're correct.
Where it goes through the middle of that.
So all a y-intercept is where my line crosses the y-axis. Where the line crosses the y-axis. That is my y-intercept. Sweet. What else do we know? Anything? Look back at your slope formula. How did that slope formula read?
Change your model.
Yeah, what's the formal formula? The one I started with. That's not where it started. That's what I'm talking about, but that's not where it started. What's the very first thing I wrote on that formula? Nope, that wasn't the formula. That was the definition. So if I go back here, if this is in y equals mx plus b slope-intercept form, what do you think about that m? M is the slope. Okay. Let me get all this. Let me get this straight. This is called slope-intercept form. Is that right? And what does slope-intercept form tell me? It tells me the slope and the y-intercept. It's a form of an equation that tells me the slope and the y-intercept. What do you guys think we should name that form that tells me the slope and the y-intercept? Slope-intercept form. That's a great name because it's called slope-intercept form and it tells me the slope and the y-intercept. Don't think mathematicians are out to get you. Look, they couldn't have made it any easier. Slope-intercept form. The slope and the intercept. Sweet. So, for this particular equation, y equals 4/5 x plus 2, what is my slope? 4/5. Yeah. What's my y-intercept? If I know those two things, it's as easy as can be to graph. Tell me how would I graph?
Start it. On the y-intercept.
You always have to start with a point. This time the point I know is the y-intercept. The y-intercept is 2. That means it crosses the y-axis at 2. So I put a point at 2. And now I need another point. Did y'all learn in geometry? Through any 2 points there exists exactly one line. So if I'm trying to draw this line, I just need another point. Well, where's the other point at? I can use the slope that tells me how much to rise and how much to run to find another point. Okay, here's the most common mistake I see when people first do this. Where am I rising and running from? The point I already have, the y-intercept. So from this point, the slope is 4/5, meaning I need to rise 4 and I need to run 5. 1, 2, 3, 4. 1, 2, 3, 4. One other thing I want to mention here, both of these numbers are positive, right? Positive 4 and positive 5. That means a rise of positive 4 means I'm going up 4. If it was a negative, I would go down. The run is also positive, meaning I'm going to the right. So I'm going up and to the right. Up and to the right. How many times can you do that? As many times as you want to. If you're bad at drawing straight lines, you could do it again. So from this point, I could rise 4. I could run 5. Puts me here. I could rise 4 and run 5 again, but it would put me off my graph. But I really stink at drawing lines. So I want some more points. How else could I find some points that are on this line? Because like this is all you need, right? Like this is good enough. And I could keep going this way, but how could I find the points that it goes through over here? I could go down 4 and left 5. I could make them both negative. Because remember, slope is just division. It's just a fraction. And 7th grade math, what's a negative divided by a negative? It's positive. So negative 4 over negative 5 still is a slope of positive 4/5. So I could go down and to the left. And I'm going to do that down 4, left 5. Again, it's because I draw terrible lines. And I can do it again, down 4, left 5. And so the more points I have, the better my line looks. Wow, that's how you take 50. You are given a line. I know this will probably be hard to take notes on. You're given this line, and I'm asked, what is the equation of this line in slope intercept form? So if I've got to put this in slope intercept form, what do I need? So great. That's all you need is the slope and the intercept. Because then you can put it in slope intercept form. What does slope intercept form look like? Y equals mx plus b. I remember m is the slope because I wrote it on that first slide that we did together. I did. And the b is the y-intercept. So, okay. Can anybody tell me what either one of those are from the screen? The slope or the y-intercept?
The y-intercept is 1,
How do you know?
because it's like the first dot on the y-axis is on the 1.
Yeah. Here's my y-axis. Where does it cross the y-axis? At 1. So the y-intercept is 1. Sweet. So I'm going to put 1 in for my b. And only thing I need is the slope, m. -3/4. They made this one very easy for us, didn't they? From a dot from here to here. These are the first 2 points that are on a crosshair. You guys know what I mean when I say that? Like, you see like how you got all these crosshairs that are like perfectly lined up? This point and this point are the only two that go directly through a crosshair. You see how this misses and this. So you're going to pick points that are on crosshairs and then figure out the rise over the run. So if I went down 3 and right 4, that means I rose -3 and I ran +4 because I went to the right. Stop listening to me, watch. And that's it. Questions on that one? All right, let's try. So we need to write an equation in slope-intercept form of the line passing through the points 5, 4, and -1, 6. All right, so help refresh my memory here. If I'm writing an equation in slope-intercept form, what do I need? The slope, that's a good one. And the y-intercept. Right? If I know those two things, remember slope-intercept form needs the slope and the y-intercept, then I'm good. So do I know the slope? No. Do I know the y-intercept? No. Right? It doesn't tell me the slope. It does tell me 2 points, but neither point is the y-intercept. How do we know neither one of these are the y-intercept? That's correct. For the y-intercept, the x would be 0, and neither of these have an x of 0. So I'm kind of stuck because I don't know either one of the two things I need. But because I do know 2 points, I have enough information to find the slope. How do we find the slope when given 2 points?
Y2 minus y1 over,
The slope formula. Right, we made a big deal of that. Or I did. Maybe y'all didn't. So, it doesn't matter which one you make x1, y1, and which points you make x2, y2. You just need to pick. So, for me personally, I would make this x1, y1, and I would make this x2, y2. But if you do it the other way, it's fine. Does not matter. The reason I would choose this is whenever I have negative values, I like making those the first ordered pair. And you'll see why in a second. But it doesn't matter. So plugging in, y2 is 4 minus y1 is 6 over x2 is 5 minus x1 is negative 1. So I've got a subtraction in the formula, and I'm subtracting a negative number. So I don't know how you guys are used to doing this, but if I subtract the negative, I just make it a positive. Does that seem familiar to you guys? Y'all do that? I don't know. Different teachers teach different things. So 4 minus 6 is negative 2. 5 plus 1 is 6. So I've got negative 2 over 6, which will simplify to be negative 1/3. And that was the slope. Any questions about how I found the slope? Okay, so to find the y-intercept, let's talk about slope-intercept form for a second. Y equals mx plus b. So what do these different variables, let's start with this. How many variables are there in this problem? Do you know what a variable is? How many are there? There's 4. There's a y, an m, an x, and a b. So there are 4 things that we don't know. Think about any line that we would draw. So if I drew this line here, let me backtrack. What do each of these 4 variables represent? We talked about 2 of them specifically on Monday. What does the m represent?
Slope.
What does b represent? Okay, that's the 2 we talked about. What do x and y represent?
X and Y points.
It's any x and y combination that is on this line. So the x and y could be 0, 2. Or the x and y could be negative 3, 0. Could be, I gotta keep the same slope here. It could be 3, 4. Okay? All of these are points that are on that line. So, thinking about this line, does the slope ever change anywhere on this line? No, that's the whole point of a line. It has a constant slope. Never changes. Does the y-intercept change on this line? What's the y-intercept of this line? Does that ever change? For this line, no. It's always 2. What about an x and a y that's on this line? Is 3, 4 the only ordered pair on this line? I could pick any of these, or any other ones that I don't even have labeled, right? Like all of these make the equation true. So, what I'm telling you is the M and the B never change. The slope and the y-intercept are always the same for the line. But the x and y could just be any point on the line. There are infinite number of x's and y's that we could find. That's why we don't normally find the x and y. We just leave them as x and y. It's any x and y that would make that true. So, thinking about that, I have 4 unknowns. How many of them do I know? Well, I have found the slope. That's the m. That's one unknown that will never change. It's always negative 1/3. I don't know the y-intercept. But what about x and y? Do I know a point that would make this true? I know a couple of points that would make it true. And either one I could plug in. And think about what happens if I know the x, the m, and the y, or I know the m and an x and a y, I can then solve for one unknown. When I just have one variable that I don't know, I can find that by isolating it. So that's all we have to do then. We're going to pick a point. I would pick the one where both values are positive. I don't like working with negative numbers if I don't have to. So I'm going to take 5, 4. I'm going to plug 5 in for x, 4 in for y, and I already found out the m, or the slope, was negative 1/3. So I know 3 of the 4 values, plug them in, find the missing one. That's going to give me 4 equals negative 1/3 times x, x is 5, plus b. And so now then it's just a 2-step equation. Right? Get b by itself. So first I need to multiply. Negative 1/3 times 5 is negative 5/3. Then add 5/3 to both sides. So negative 5/3 plus 5/3 cancels. So that's going to leave me with b equals, and then adding 4 and 5/3. You guys know how to add 4 and 5/3?
The 5 and 2/3.
Oh, gosh. Yes, man. Sure. We hadn't had this conversation with you yet. I haven't had this conversation. I hate mixed numbers. Oh my gosh. I could take the mixed numbers. Stack them. No offense to your answer. You're correct, but just the mixed number part. Just.
So you want 17 over 3?
Yes, that sounds much better. Thank you so much for that. So, when I'm adding a fraction, I appreciate you already knowing how to do that. And you do that in your head, or did you use your calculator? Okay, that's good. Most people can't, so that's fine. I'm just finding out who can, who can't. Anybody else do that in your head? Yeah, okay. There's something. It's okay. It doesn't matter. As long as you can do it, I don't care how you do it. So for everybody else that can't do this in your head, how are you going to add this fraction to this number? We don't know. We don't know. Okay, is that we don't know? Or are we quiet? Quiet, don't know. Quiet, don't know. It's okay. That's fine. I'm just finding out. Adding fractions. This is very important. So if you need to make a big note, if I need to make a big note and put it up there, I will. When you're adding fractions, you must have a common denominator. Must have a common denominator. But I only see one fraction. Well, I can make the other number a fraction. Just put it over 1. Can always put any whole number over 1. And now the common denominator would be 3. So I need to multiply 1 by 3, which means I need to multiply 4 by 3. So 4 times 3 is 12 thirds plus 5 thirds. So 4 and 12 thirds are the same thing. Right, if I had 4 whole pizzas, I cut each pizza into 3 slices. Who does that? But you can. You would have 12 slices, 12 thirds of. That's fine. That's fine. I don't care. I don't like y'all either. So this is over 3. When you add fractions, you keep the denominator the same. Combine the numerators. 12 plus 5 is 17 thirds. So the y-intercept here would be 17 thirds. So what was the point of this problem? To put it in slope-intercept form. Slope-intercept form. What things do I need to put something in slope-intercept form? The slope and the y-intercept. Do I know those things? I do now. Plug them in because they never change. So y equals negative 1/3 x plus 17 thirds. Can you imagine if that didn't say 17 thirds, if that said 5 2/3? No, it would not. I would vomit. No, this is, Algebra 1 is officially the time that you're probably never going to put a mixed number answer down ever, never, never, ever again. So, just so you know, you got to get used to working with improper fractions. I forget that, like, when y'all are just like little, I know y'all had geometry, but that's not really a math. It kind of is, but it's not. You know, it's its own little, it's like way out here. And you're just little 8th grade baby mathematicians that I've got to mold you and turn you into Algebra 1 students. We'll get there. We'll get there. She gets a medium coffee. The graph shows the gift card balance at 2 points. How can Allie determine the number of medium coffees she can buy with the gift card if she doesn't know the original value of the card? So let's take a look at this graph and see what's going on. Our Y values represent how much money we have on the gift card, and our X values represent the number of medium cups of coffee. So when I look at this point, can somebody explain to me in words what this point is saying?
That's how much it is for her to buy 2 cups of medium coffee.
Okay, not quite. You're correct in one part of it. It is 2 cups of coffee. That's correct. That's how much is left on the gift card. That's not how much it costs for 2 cups of coffee. So after 2 cups of coffee, Allie had $19.70 left on her gift card. After 4 cups of coffee, Allie had $14.40. So we can see the more cups of coffee we get, the less she's going to have on her gift card because it's a negative sloped line. So we're trying to figure out the number of coffees she can get. So we really are looking for how long is it before she has 0 money on her gift card, right? So let me just show you this. If I just had to guess, just straight up guessing, if I could draw a line, it looks like it's going to be somewhere between 8 and 9 when she runs out of money. You see that? I mean, that is very unscientific. That's not what's going to be my final answer. But I just have a good estimate for when I do the actual calculation. If I get something crazy that's not close to 8 or 9, then I know I messed up somewhere. Does that make enough sense? Like just going in. Okay, so what I would do is I would try to find the equation of this line. So how can I find the equation of this line? It's the exact same problem we just did without words. I know 2 points. If I want to put it in an equation, I need to know the slope and the y-intercept. Does that give you enough information? Could you work it from there? Or do I need to keep going? So that is 5 and yeah, if I was working this at a different time, I definitely wouldn't do the equation. I would do this differently. But I still would use the slope.